So in this case, so on the of n of s will be equal to say 6 power 2, which is a power b, which is 36. So what is this telling? This is telling that if you talk about an experiment of throwing two dice together, or throwing a single dice twice and observing what is the result could be 36 different possibilities. So what are those 36 different possibilities? Those are, can write as 1. So as we write h comma hh for the coins, we can similarly have the cases. So first one indicating the result of the first dice or the first throw, second one indicating the result of the second dice or the second row. So we are using brackets. We can't just directly write it as hh 1 1 anta barada 11 anta misread ಆಗುತ್ತೆ ಅನ್ನೋ ಕಾರಣಕ್ಕೆ 1 1 ಅಂತ ಬರೆಯೋದು. ಸೊ ಇಲ್ಲಿ h h ಅಂತ ಬರೆದ್ರು ಒಂದೇ ಅಥವಾ hh ಅಂತ ಬರೆದ್ರು ಒಂದೇ. So it is indicating the same. First one the result of first coin or the first row, second one indicating the result of the second coin or second. So the 36 possibilities are 1 1 1 2 1 3 1 4 1 5 1 6. So this is the case where your first dice is showing the number 1 and the second dice could be any number between 1 and 6. Now similarly you can have the outcome where you will have first one to be outcome as 2, the second one is 1 2 again 6. So 2 3 2 4 2 5 and 2 6. And then you could have 3 1 3 2 3 3 3 4 3 5 3 6. And then you could have 4 1 4 2 4 3 4 4 4 5 and 4 6. And now, since the sample space is a bit large here, you can talk about various such possible events. So you could have a case, of your interest where you need both as even number, both as odd number, or both prime numbers, or both the numbers less than 7. You compare and dice so throw the dice and bet. The betting will be for 3 cases. Below 7, equal to 7, above 7. And if you look into the case 7, how the 7 is defined, it is defined as the sum or the product. So, ಎರಡು dice na ನೀವು throw ಮಾಡಬೇಕು. ಈಗ ನಿಮ್ಮ event is based on the sum of outcomes. That is the total of outcomes. Now, the sum of outcomes are given into 3 cases: less than 7, equal to 7, greater than 7. So I'm just taking a simple example here. Now you want to bet the amount. Now, if you look into the favorable cases for the sum less than 7. So ಯಾವ cases ಅಲ್ಲಿ total less than 7 ಇದೆ. So less than 7 cases are say 1 1 1 2 1 3 and then up to so you are just looking into the less than cases. These are the favorable cases for sum less than 7. Sum ಅಂದ್ರೆ add ಮಾಡಬೇಕು. 2 plus 1 3 2 plus 2 4 and pick the cases which are strictly less than 7. And what are the cases with equal to 7? Equal to 7 are 1 6 and then we have 2 5 3 4 4 3 5 2 6 1. So these are the cases for equal to 7 and the remaining are the cases for sum more than 7. Now you see in which case the chance is very high. So you have 1 2 3 4 5 6 cases only for equal to 7 and then you have 15 cases for less than 7 and 15 cases for more than 7. So ನೀವು equal to 7 ಗೆ bet ಮಾಡಿದ್ರೆ you are likely to lose because it is very rare, only 6 cases, but you can win for in the cases if you bet it for less than and greater than. So ಎರಡು equal chance ಇರೋದ್ರಿಂದ you have to try your luck only on greater than and less than case. So that doesn't mean that equal to 7 ಬರೋದೇ ಇಲ್ಲ. We are not telling that it is impossible. We are just telling that it has less chance of occurrence. It has less chance of occurrence. So it could have various such events. What is the question could be like, find the probability of first one getting same number, getting a sum as greater than 5, or get is the probability that the product of the numbers product is equal to 6, or the case of event where say product is more than 10, or both are odd numbers, both are even numbers. So various such events could be looked, and full marks will be only given if you have correctly written the event, their favorable outcomes, the notations n of e1, n of e2, n of s, all these 36 elements of the sample space. So the problems what I have just taken on the board, they are very simple to understand the mathematical definition of probability. You have, it is very easy to write the um, sample space as well as events, and probabilities could be easily obtained. But these techniques, these are very helpful to understand the terminology called as probability. But when you look into the real life situation, so you can say that since I have 15 cases here, I will bet, say some 100 rupees on this event, then I'll pick the dice, I'll, shuffle and I'll throw them. I could end up getting equal to 7, less than 7, because if you look into the total possibilities for this, it is 21 versus say 15 of this. So this is more. So in real life, exactly dealing with the probabilities using this equally likely doesn't help us. So you cannot always have the assumption of equally likely. What is equally likely? The chance of one outcome is same as the chance of other outcome. A simple example, another example to understand what is equally likely and how it fails in the real life. So we have already, very much familiar with the game of dice or snake and ladder. We have played so many games in our chapter. So whenever we are playing in a particular board, after climbing a lot of ladders, so I'm in the very last position. So my dice or my pawn is here. So if I want to win, I just need the number 1 on the dice. So we will take so many number of trials. So even after, throwing the dice for 10 times, 20 times, 30 times, I could never get 1, and the other player, most of the cases, he will easily win. So equally likely, what is this equally likely? Equally likely tells that if you take 6 throws, in those 6 throws, you would observe 1 to 6, not in that order, in any order. That is equally likely. If you take 12 throws, then you will observe 2 threes, 2 twos, 2 ones, 2 fives, 2 four, 2 six. Now similarly, if you are making say some 60 throws, then you will observe 10 times 1, 10 times 2, 10 times 3. But that is not happening in a real life situation. I took 20 throws, but not even for once I got the number 1. So this assumption, when it comes to real life, it is not valid. So in those cases, obtaining the probabilities using the mathematical approach becomes wrong and invalid. So in that case, we need some other techniques to obtain the probabilities, and therefore we define the definition, or we alter the definition in such cases, and we call that as statistical way of computing the probability. So when we say statistical, we mean the approaches based on the data. So whenever you are talking about experiments where sample space are not involved, so let me take say an example. So I'm boarding a particular flight with say number 23A67. So it is going from say Mysore to Bangalore. Now, as a traveler, I need to answer this question. What is the chance that I land safely? So even if the pilot says that there is 90% chance that he will land safely, so he is not giving guarantee for the remaining 10%. So would you take chance and board the plane in those cases? So coming up with an answer, how did the pilot answer me that it is 90%? On what basis? So if I'm talking about an experiment like this, what is the sample space there? You can't define sample space there. You can't just say it is yes or no. Will land safely, will not land safely. No, that is not only the possible cases. You cannot just come down to only these two cases because so many technical aspects are involved. You might be knowing from your end that it is a safe landing, but pilot knows all the troubles what he experienced in the cabinet before landing the plane. The planes are nowadays equipped with such that multiple engines will be there. Even a failure of one engine doesn't cause the trouble landing. So as a passenger, you don't know that, but as the staff or the crew, they know what exactly is happening. So for you, it is a safe landing. The safe landing for you need not be a safe landing for the pilot. So they had some switches not working properly. Some of the crew or some of the pilot, they just became unwell. Some of the passengers got unwell. There were some technical issues. So in most of the cases, for the passenger, these failure inside the cabinet or with respect to crew, that is not, let known to the passenger. They will just hide it because, it will create a hoax and some other issues causing, a much trouble landing. So it is very much difficult to come up with the sample space. This is case one. Case two, you're talking about an infinite sample space. You cannot say what exactly is the end there. Say, for example, if you're counting the deaths because of COVID, it's going on, that's crossed or almost 3 lakhs, 5 lakhs, and so on. But the number of deaths could be this. Or it's simply if you're counting the number of thefts happened uh, in a locality. So how many thefts will be happening in a locality? So you could say 0 thefts, 1 theft, 2, 3, 4. You cannot exactly say there will be only 10 in this week, there will be only 0 in this week. So the sample space is infinite. So in those cases, computation of probability comes with what called a statistical definition, and there we say you already have conducted the experiment. So whenever you conduct the experiment, record the data, record the outcome. And using that data, you can define the probability. And if you're talking about any event E with respect to these cases, there we say limit n tends to infinity m by n as the probability, where m is the number of favorable outcomes out of n trials of experiment, and this limit is not that hard. It simply says n is large. Okay, so now we got an answer for this question. So in the past, this particular flight has taken many flights between Mysore and Bangalore. So let me say it has taken say 100. Even doesn't matter a new flight, if it is very first flight, we'll start recording the data from day one. So from past 100 days or 100 flights, I have the data. So totally this flight has taken 100 flights. Out of these 100, almost 95 times it has landed safely without any issue. And in 5 of the cases, we had some technical problem like engine or the switch or the crew problem. Crew was late. Something happened which, landing was successful, but, the chance of failure or in 5 cases, something happened there. So this is telling that out of 100, 95 times you have landed safely. Therefore, probability is equal to 95 divided by 100, which is m by n. So what is it telling? Conduct the experiment for 100 times. see how many times you got your favorable outcome, then that ratio is probability provided n is large. For smaller cases, like say, if I'm talking about, say, the flight has taken 2 times and all the 2 times it has landed successfully, then you cannot say 100% successful rate. So you cannot talk about probability in these cases where your M and N is very large. Now coming to the case where you want to answer how many thefts will happen in the coming week in a particular locality. So to answer that question, that probability, you know already how many thefts have happened in the past per week. So get the data, say week 1, week 2, week 3. So let me say that you are gathering this for almost say some 80 weeks. Then you are recording number of thefts. So 0 thefts, maybe 1, 2, 3, 4, maybe 5 total. And this is number of weeks. So we have already learned how to collect the data and how to create the frequency distribution. The same concept is here. So you have X number of thefts and how many weeks this happened. So out of the 80 cases, 80 weeks data, out of this 80, in 20 cases, you had 1 theft, and in 0 cases, you had 0 theft in 0 weeks, and in say 40 weeks, you had 2 thefts, and in the remaining 10 cases, you had 3 thefts, and then maybe 5 weeks, you had 4, then you have almost 75, another 5 here produces 5. So you have this. And while talking about the frequency distribution, we looked into what called as relative frequency. R is equal to F by N, the ratio of frequency to total frequency. And now if I use that concept, 0 by 80, 20 by 80, 40 by 80, 10 by 80, 5 by 80, 5 by 80. So this relative frequency is actually a definition. P of t is equal to limit n tends to infinity m by n. You could say that, so you're not applying the limit. We are not talking about the mathematical limit. It is mathematical limit, but it simply says that n should be large. Only then the probabilities make sense. Otherwise, they are just some numbers. So if I want to answer what is the chance that 5 houses will be under suspicion of theft, then probability that 5 houses in the coming week will be suspected for a possible theft, then that probability is 5 by 80, very less. Or you could say, what is the chance or maximum thefts which can happen in this week? You can say the maximum chance is 40 cases, which is for 2. So in the past, we have observed 40 weeks or 40 times 2 thefts have happened. So even in the coming week, I'm very much sure that 2 thefts will be there. So if possible, you can identify those particular cases, or you can take enough measures or assign a particular police for every particular house or a particular street, and you can just try to avoid those cases. So this is how probabilities are computed. As said, this should be large to make sense. So if n is large, then your R is equal to F by N actually produces probability, and your relative frequency is nothing but probability provided n is large. Provided n is large. This is how we use the data to compute the probability. So this is only by experiment. Now every now and then we collect the data. So as time advances, I could get the data for 81 weeks, 82 weeks. So update your data and revise your probabilities. That is what the data scientists are doing. Okay. Now what is the let's say logic that whatever has happened in the past remains the same. Now this is called as the concept of moving average, or simple logic there. So if every other aspect is same, that is the conditions, you could simply, to put in simple phrase, the environment in which the experiment is happening is same, unless the mother nature interprets it, then things will be the same. So that is called as error. Now this error could be a case where because of the nature or because of human interference. So if there is no error, then whatever you have experienced, the same will be there. So using that logic, we say whatever we have observed till now, even in the very immediate future, the things will be same, unless because of these two cases that change happens. So you can see, if you look into the data or the marks of the students, or say price of the gold, so just they remain the same, but slightly it varies because of the increased involvement of the purchases or the transactions, or the variations in the stock exchange areas, etc. So otherwise, we say whatever we have observed in day one, day two also it is same, day three is also it is same, but there will be something called as error. So we try to minimize the error, then we can actually predict what is happening in the future. So that is what the predictive model using the probabilities nowadays they are working in. So look into various such problems involving the combinations also. Try and understand the concept of NCR, and you can really go through the chapter 9. Today I could just look into chapter 9 of first PUC, which is your just the probability. Okay, so understand these two concepts and all the terms related to probability. You have events, different types of events. There are certain rules of probabilities called as addition theorem and multiplication theorem. So please go through them also. Addition and multiplication theorem. In the next class, I look into the other aspects of probability. So these things are roughly sufficient for you. So I'll talk about what called as conditional probability, and then we will actually look into what called as probability distribution. So we have studied what called as frequency distribution, univariate frequency distribution, bivariate frequency distribution, and we learned how to compute the means and variance of those frequency distributions. The next class will try to understand what is called as probability distribution, and we'll see how we can generate the mean and variance of the probability distribution. Okay, so I'll stop here. If you have any doubts, you can ask. Okay. So I and Lancy sir have decided that those who regularly attend the classes, only for those the tests and assignment marks will be given, and those who are very much irregular, no marks, internal marks will be given. So I'm planning on giving some assignments. So I'll look into some past attendance, and I'll give you some individual assignments. So I'll give you around 2 weeks of time to complete those assignments and to submit them. Okay, so if I have anything, then